Hi everyone, welcome back to my YouTube channel Tech Data Engineer. So in this video, we will see what is BigQuery architecture, what is like how the data is getting stored, and what is the brain of this BigQuery, and how data is getting executed, and what are the different architecture, what are the different engines in BigQuery, what are the BigQuery architecture, and then some hands-on, okay, how to create the data sets, project ID, and how to query the data, okay. We will see all these things, partitions, clustering, metallized view, and everything, the details, okay. So let us start with simple definitions of BigQuery, right? So everyone aware with the BigQuery who have worked with the GCP. So BigQuery basically is a it's like a data warehouse, right? So BigQuery is like a service, it's like a GCP services for data warehouse, right? So BigQuery is basically is a serverless, fully managed, distributed data warehouse for analytical at massive scale. Okay, so if you are working in AWS, we have Azure Web Services. Okay, we have Azure Web Services, we have Redshift. So in AWS we have Redshift. Okay, Redshift, and other we have like Azure we have like Snaps, something like that. Okay, so we have that. So this is basically in the GCP cloud. Okay, BigQuery is GCP cloud. So BigQuery is like a serverless, fully managed, distributed data warehouse for analytical at massive scale. Okay, so you don't have to worry. So whenever you have created BigQuery, you don't have to worry about how to manage the server, how to store, how to do the indexing and partitions and all these things. Okay, everything is done by Google itself. Okay, just you have to load the data, write your SQL, and get the result. Okay, so this is a step you have to do. Okay, so you have to write your SQL, load the data, write SQL, and get the result. Okay, so that's why BigQuery is I can say scalable at very good level. Okay, so let us start with the BigQuery high level architecture. Okay, first I'll explain the BigQuery architecture. Okay, so we will see BQ architecture. Okay, we will see BigQuery architecture. Okay, so before explaining the architecture, think it like that. Okay, so suppose this is your data. Okay, this is your data. Okay, this is your data. So data should be it is either in the CSV or JSON or Parquet. Okay, anything. Okay, okay. So this is your data. And then you either what you will do after the data, you will do either you will do the load or a stream, or you can use as a external. Okay, then what you'll do, you have the BigQuery storage. So this is the external data. You can use BigQuery storage. Okay, that is basically we need to know that is basically columnar. Okay, or compressed also. Okay, that is the benefit of storing BigQuery storage. Then after BigQuery storage, we have distributed query engine. Okay, distributed query engine. Okay, distributed query engine, that is called Dremel based. Okay, that is the Dremel based. Okay, then after that we have SQL result. Okay, so this is the processing engine, SQL result. Okay, So this is the architecture. So this is your data, this is BigQuery storage, and that is the Dremel based. You will get the result after getting the uh, like after you, whenever you are writing your queries, so you'll get the SQL result. Okay. So before that, we will understand, first we will understand BigQuery core component. Okay. There are some core component. We need to understand that before understanding the BigQuery details. Okay. First is called storage layer. Okay. Storage. First is storage layer. Okay. So I'll explain these two things. Okay. So storage layer we have. I'll so a storage layer. So what storage layer in BigQuery storage layer we have Colossus. Okay. Colossus. Okay. So BigQuery store data in the columnar format. Okay. So whenever you are storing the data, okay, it is storing in the columnar format. So what is columnar format? Like suppose you are writing the things like select employee ID, comma, salary, okay, from table, okay, from employee table. So what it will do, so whenever writing your query in the BigQuery, so BigQuery only reads employee ID and the salary column, okay, not the full row. So that is the advantage of storing the data in the columnar format. Okay. So what is the benefit of using columnar format? First is the first is the less input output. Okay, less input output operation. Second is the faster queries. Okay, because only it is trying to retrieve the mentioned column name. Okay, faster queries. Then third is the cheaper cost. Okay, cheaper cost. Okay. And so other feature is, this is the result, right? Then other features we have like a automatic compression automatic replication, auto replication. These are the feature of storage system. Then we have the decoupled from compute. Okay, so this is basically the storage layer and the compute layer is different. Decoupled from compute. Okay, decoupled from compute. Then first is the storage layer. So we understand the storage layer. We will see in the details what is the college and how Dremel works. Second is the compute layer. Okay. Second is compute layer. That is called Dremel. Okay. That is called Dremel engine. Okay. So this is basically brain. Okay. This is the brain of the system. Okay. So in compute engine, the queries are broken into thousands of small tasks, like, okay, so if you are writing the query, so queries are here broken into thousands of a small task. I'll explain the architecture also, a small task. Okay, and then what will happen, so every task, so this is one query, right? This is the bigger queries. So whenever writing in a big query, so this getting installed in the different task, okay, and this each task running parallelly, okay. Then after running, it is getting joined. It is this two tasks getting joined and coming to the one final solution. Okay, so task runs final. This uses the tree architecture. Okay, so what is the tree architecture? So in compute layer, the tree architecture is like, it's like a root server. Okay, root server. Then other is like intermediate aggregation. Okay, intermediate aggregation. Like this is the root server. This is the intermediate aggregation. Okay, merging this all three. And then we have the leaf node, like this is the leaf node first, this is the aggregator, intermediate, this is the final. Okay, so leaf node scanning data. Okay, so leaf node scanning data. Okay, so in this video, so you can understand, like we have the root server, intermediate, and leaf node. Okay, so first we will understand what is Dremel and what is Coalesce, and then we will see, if you will understand this, you are good with the BigQuery architecture. Okay, then we'll understand what is the project structure and all these things in BigQuery. Okay, so let us understand. So with Coalesce first. Okay, so in Coalesce, so Coalesce is basically is a global distributed file system. Okay, first we will understand what is Coalesce and what is Dremel. Okay, so we understand we have the storage layer where Coalesce is working, and compute layer where Dremel engine is there. Okay, so I already explained how get data is getting stored in Coalesce columnar format. What is the benefit of that? What is the automatic features they have? Then we have compute layer. How, what is the architecture it is following, like root, intermediate, and leaf node. Okay, so how like million or billions of data, like petabyte of data is getting scanned in a seconds because of this functionality. Okay, because queries are broken into thousands of small tasks and it is getting computed parallelly. Okay, so before that we'll understand what is Coalesce. Okay, Colossus. So we'll understand what is Colossus. Okay, what is Colossus? This is basically BQ, a storage engine. Okay, storage engine. Okay, so what is Colossus? So Colossus is a Google's. It is basically, it is it is it is Global. It is Google Global Distributed File System. Okay, distributed file system. Okay, so it is basically used for a storage layer. Okay, so it is the storage layer for BigQuery. Okay, so think of Colossus is like a, it's like Google Brain for storing massive data in reliable and cheaper way. Okay, so why college exists? So because a traditional database store data in the local disk. So there was a issue with the traditional database. What was the issue? So traditional database store data in local disk. Compute and storage are tightly coupled, like both are linked, right? And scaling is painful. So because of that, we College solve this all this problem. Like they have the unlimited scale. So what is the benefit of using College? Because unlimited scale. Scalability is not an issue. High durability, like because of you can say, because of multiple replications, they have the high durability. Then third features, it has separations of separate storage, storage versus compute. Okay, so in BigQuery there is separate storage and separate compute, and there is a cheap storage. Okay, cheap storage. So these are the benefit of using Colossus. Okay, so how Colossus store the BigQuery data? We will see. So we will see. Like suppose we have the data, like it, so basically it is store data in the columnar format. Okay, columnar storage. So suppose we have like a order ID, then we have customer ID, then we have CT, then we have amount. So everything, so how this getting stored? First is the order ID, then their value. Whatever their value, it is getting stored here. Then customer ID, whatever their value getting stored here. Then we have the CT, whatever their value is getting stored here. So these are the columnar storage. So what is the benefit of using columnar? So each column is stored separately. Okay, so each column is stored separately. Okay, so if only we want this column, the data is getting scanned from this column only, not in the row level, like every column is getting scanned here. So only the required column is getting scanned. That is the benefit of using columnar storage, and that is compressed also. Okay, compressed also. That is the benefit of that. So if I'm explaining, I'll explain bit more details. So what are the encoding techniques college using? So they are using the college applied dictionary encoding. Okay, dictionary encoding, then run length encoding, then we have delta encoding. These three types of encoding. This Colossus is working. Colossus is storing. Sorry, using. Okay. So suppose there is a column called city. Okay. So there is a column called city, and where data is like Delhi, Delhi, Delhi. Then we have Bangalore, Bangalore. So how data is getting stored? If you know, so data is getting stored like Delhi into 3, because this is the 3 time. Okay, Bangalore into 2. So this way it is getting stored. This way it is getting stored. Okay, that is called the encoding technique. So compressions or encoding technique. So because of that, we have the less data storage, less data scan, faster queries, and lower cost. So these are the advantage of using this system. Okay, storage system as a college. Okay. So, if you talk about the physical distribution, so data is split into blocks. Blocks are stored over thousands of machines, and this is automatically replicated. So, no data loss. Locations awareness, like closed data, it is reading first. So, because of that, it is bit cheaper also. Okay. So, what is the benefit of that? So, first is, so we have already seen the advantage is like decoupled. Okay, decoupled. First is the benefit of that. First, then we have the durability. Durable. Third is scalable. What is the fourth benefit? That is cheap. What is the fifth benefit? We have like fast input output. Okay, so these are the benefit of using college. Now we will see what is Dremel. Okay, what is Dremel? Okay, so that is basically big query engine. Okay, so BigQuery query engine. So first we understand what is the BigQuery storage engine and what is query engine. Dremel is basically a massive parallel SQL execution engine. It is basically massive parallel SQL execution engine. Okay, this is called Dremel. So Dremel is basically so Dremel so it what it does basically, so if this is our Colossus means like a storage system, storage. Okay, so our Dremel, this is our Dremel. So it reads data from this Colossus, and it reads data from Colossus and answer your SQL, whatever you are writing the SQL. Okay, so what is the core problem Dremel solves? So how do you run a SQL query on petabytes of data in seconds, right? So because of so this types of problem basically it solves. So how it solves the problem? It breaks the query into thousands of small tasks and run them into parallel. Okay. So I'll explain the Dremel architecture also. If I'll explain the architecture, that is basically a root server. Okay, a root server. That is basically root server. This is called final aggregation. Then we have the intermediate server. These all are intermediate server. Okay, intermediate server. These are intermediate server. Okay, then we have the third, we have the leaf node. Okay, that is leaf node. Leaf node here also, leaf node. So what is leaf node? Basically read data from Coalesce. Okay, read data from Colossus. Okay, so this is the architecture of your Dremel engine. Okay, so suppose I'll take some example also. Example with this one. Okay, so I'll write some query and then I'll explain how it is using the Dremel with query. So select CT, then I'm writing sum of amount. You can consider anything from orders. I'm taking the order table, suppose orders where order date equals to anything, right? Any date you can consider, and group by CT. Okay, group by CT. So what is so how basically this particular query runs, right? So if we wanted to understand that, we need to understand first step is the query planning. Okay, first step is the query planning. Okay, so query planning means Dremel pass SQL. It's applied partitions pruning, applies column pruning, build executions plan, and then what is the second step? We have read data from it, scan the data. Okay, scan data from Coles. So read only the required column. So what is the required column? We have CT and other is amount. So only it is reading these two column. Read only the required partitions. So partitions like order date is like something. Whatever the date I'm giving, so only that partition it is reading. Okay, and read data from Colossus in parallel. So because of this nature, and then the local aggregation like final aggregation. So if we are only finding these partitions and this column, and then it will do the final aggregation based on the different conditions. So these are the benefit of using Dremel and all. Okay, and because of this backend execution brain, like our big queries is scanning petabytes of data in second. Okay, so that is the advantage. That's why I have explained it details. Okay, now we will see. So we understand. So Colossus is basically a storage engine, and Dremel is basically a that reads data intelligently. Okay, so that is basically for query things. Okay, now coming back to our big queries related things. Okay, so we understand the big query architecture. What is Dremel? What is this and all? Okay, now we will see some architecture. So now now we will see how data is getting organized in the big query. So if we'll see BigQuery data architect, BigQuery data organization. If you'll see BigQuery data organization, so first we have project. Okay, first we have the project. Under the project, we can have multiple data set. Okay, data set, data set one, data set two, something like that. Okay, data set one, data set two. We can create multiple data set, and each data set we can create multiple table. Okay, table one, table one, table 2. Okay, something like that. So whenever you are you can querying your data, so you have to do like, so whenever writing your query, okay, so you have to do like project 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 id dot dataset dot table. So always remember, this is the structure of your big query. Okay, so whenever I will do hands-on, we will see. So how data comes into BigQuery? So data comes. So how data comes into BigQuery? So first is the batch mode. Okay. First is the batch mode. Batch mode means we have the CSP, JSON, Avro, Parquet. You can write batch mode and you can get your data. That is from the either GCS, local files, or from other warehouse. Other method is from a streaming insert. Okay, you can do the streaming insert also. Okay, you can do a streaming insert, and the streaming insert like you can use the real time events or Kafka data flow BigQuery, something like that. Okay, and third is the external table. We can use external table to query the data. We can use external table also, like query data without loading. Okay, so we have GCS, we have GCS, we have Google Cloud, Google Drive, not Cloud. We have Google Drive, we have Big Table. So without loading the data directly, you can query from all these things. We have Cloud SQL also. Okay, so you can directly use your engine. You can directly use to query the data from all these things. That is called external table. So there are three way to bring your data to the your this one BigQuery. Okay. Now we will see some hands-on. Okay. Now we will see some hands-on. Then I'll explain what is partitions and what is how we will do the BigQuery optimizations and all. Okay. So then we will, so lastly we will see. Then we will explain what is the BigQuery cost model and everything. Okay. So now let us go to this one. So I'll go to Google Cloud. Okay, SQL. Okay. Google Cloud Console. Okay. So open your okay, open to console. So here, if you see here, I have already created my project Cloud Composer. Okay, so I'll search here BigQuery. Okay, so you have to search BigQuery. So this is our BigQuery. This BigQuery is a data warehousing. You can do all these things from here. Okay, so here I don't have. So this is the by default project. The data set got created. So what I'll do here, I'll create a data set. Okay, so data set ID I'll give like a test. I'll give data set name is like a test. Then I'll give BigQuery. Test BigQuery and what is the data location? Data location I'll give like US. Okay, or I'll choose the must contain only latest number underscore. Okay, test test BQ directly I'll do. Okay, something like that. Then location I'll see if there are US Central one. Okay, so I'll choose US Central one. Then I'll do the create data set. So how to create the data set? So I have already created the data set called test BQ. Okay, so you have to go to your this one here and you need to do the create data set. You'll created the data set. So if you in data set, if you wanted to do some give some permissions, so what you have to do, open. So this is the test BQ data set I have already created. So if you'll expand that, so there is no table under that. Okay, so I'll create the table and all everything, but before that I wanted to explain one more thing. So you can go to share option, manage permission. So whatever the permission you wanted to give to the data set, like if you're running some job through Kubernetes, where you are running your pod and everything. So whatever the IAM permission, which role you wanted to give, everything you can set it from here. So by default, we have the BigQuery data editor role and BigQuery data owner role, Abhishek Tiwari something, and then BigQuery data viewer, editor, everything. So if you wanted to give any role, you can add the principal from here, add principal, and if you can use new principal or existing, you can use the role from here, role like a BigQuery admin or whatever the role you want, right? BigQuery data admin or data viewer, everything, and you can create this role from here. Okay, so this way you will give the permission to your data set. Now we will see how to create the data set. So you can just click on this particular data set, then you'll get the option of create table. Okay, so you create table, you'll get all these options like, so create tables like how to create the tables. Either you are wanted to create the empty table cloud from Google Cloud storage, or you wanted to upload some CSVs or Parquet or from Drive. So different options are there. Azure Bulb storage or Blob storage, existing tables of view. Okay, so I'll give some empty table name. It's like a test. Okay, empty table. I'll choose the options like empty table. Data set is this one. project is the this one. This is the project, and table name I wanted to give like test BQ1. Okay, so this is the test table BQ table 1, BQ table, BQ table 1. So I wanted to create the first table. Okay, so partition setting, no partitions, or if you want partition by injections or partitions by field, you can give it like that. Okay, clustering order, if you wanted, you can use the tag also. If you don't want any option, you can do like create table. Okay, so if I'll do create table, like my table got created, BQT table 1. Okay, so here what you can do, if you wanted to add the schema, like edit a schema. Okay, so I'll do edit a schema, add the field. So field I'll add like a name, a string type, maximum length, not mode is nullable. Other thing is I'll do like name, salary. So salary is like a or I'll do like CT. Okay, I'll do like CT string. I'll add save it. Okay, so this name and city got created. So whatever the schema you wanted to create, you can create. You can edit the schema from here. Okay, you can add the field and delete the field from here. Okay, then you can see the details like when it is getting created, which location, what are the other things, primary key, and what how many numbers are row. So table details schema you can get it from here. Preview, like data preview, there is no data, that's why it is showing no data. You can see all these things, data quality, data profile from this particular UI. Okay, so how to create the data set, how to create the table, we have seen that. In next video we will see how to you can say use clustering, materialized view, and everything in the details. Okay, thank you, thanks for watching.